Hello everyone, welcome back to Let's Crack JEE in English. Alright, so let me check my sound. Perfect. Okay, so today we'll continue sequence and series, and we are going to discuss very important progressions today. It is telescoping series, alright. So let me start with my introduction. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for the last 11 years. I've worked with various national level institutes in Delhi, Mumbai, and Lucknow, and since last few months I'm working with Unacademy. So we'll begin this session, but let me tell you about the platform. As you know, Unacademy is India's largest online learning platform, and you can subscribe for you can take plus subscription of Unacademy. And if you take plus subscription, then what are the things you can access? Let me explain all those things. So first of all, if you take plus subscription, then you get daily live, you get access to daily live classes of all the educators who are teaching for IIT-JEE, all physics, chemistry and maths. So you can watch their live sessions as well as recorded sessions. All right. And live test and quizzes, all live test and quizzes will also be accessible to you. So whatever test, PCM test series is going on the platform, you can subscribe for that. I mean, you can appear for that. All these courses which are going on the platform are well structured. Everything is pre-planned, so you can see the schedule of all the upcoming lectures in well advance. If you're not taking the plus subscription, then what are the things you can access without getting the subscription? Those are special classes. All right, so special classes are completely free. You can access unlimited special classes. Just download the application and make your account, and you can access unlimited special classes which are going on every day. I also take special classes. I am taking special classes like today at 4:30 on functions and 8:30 doubt class. So I also take special classes. Just join those special classes and see how interactive this platform is. You can ask your doubt during the session. You can send your images, questions, images of your questions, doubts. All right, and you can participate in polls. So all the features which are there in live classes, you can see through special classes. So attend these special classes, and every day a lot of educators are taking special classes. So you can choose your topic. You can join these special classes on the topic which you want to strengthen. All right. So this was about the special classes, and also quizzes. Let me tell you about the quizzes. Quizzes are also free. Unlimited quizzes are going on the platform. So those quizzes you can appear without getting a subscription. All right. So these are a few things which you get. Like YouTube live classes are also going on various YouTube channels of Unacademy. So you can watch these YouTube channels also, live classes on YouTube channels also. All right. Now this is the subscription charges. If you take plus subscription, you'll have to pay this 38,500 for 1 year and for 56,000 for 2 years. But if you apply my code JEET1, you'll get subscription. You'll get 10% discount, and you'll have to pay this and this. All right, 34,650 and 50,400 for 2 years. All right. So these are the best packages I'm just mentioning here, and you can see the list. You can subscribe for 136 months as well. Now there's a new feature, iconic subscription. So iconic subscription is a new feature added to the platform. What is this iconic subscription? Let me tell you. So if you take iconic subscription, you get all the benefits which you are getting of plus. All right. which you are getting when you subscribe to Plus. So all these all live classes, all recorded lectures, all quizzes, all tests, all everything, unlimited access you get, or that will be there. Apart from that, you'll get a personal coach. Okay, so that is the additional thing. You get a personal coach who will guide you throughout your preparation for all the top exams like IIT-JEE, Advanced, Main, BITS. Okay, all the top exams. Uh, your test analysis will be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. All right. A study planner will also be customized according to your plan. All right. By weekly reviews that highlight your progress. All right. So these are the things which you get in a personalized manner once you take this iconic subscription. So I hope these things are clear. Now, this is the subscription charges for 1 and 2 year iconic subscription. Okay, so iconic subscriptions 1 year charges 56,000. Okay, and after 10% discount, you'll have to pay only 50,400. So you can use this code to get this 10% discount. And 2 years price is 86,000, and after 10% discount you'll have to get this much. So again, apply this code and you'll have to pay 77,400 for 2 years. Okay, and you get all the personal personal things which I've told you. All right, personal guidance, personal time management, and scheduling, exam analysis, everything. Okay, in a personalized way, apart from all the unlimited access which you are getting on the platform, which you get by buying Plus subscription. Okay, so all these features will already be there. So I hope it is clear. Iconic subscription. Now we'll start today's session. You can download Unacademy's learning app. This is the learning app which you can download from Play Store. All right, so this is the learning app. Have a look. This you can download from the Play Store. So we will be starting today. All right, just give me a moment. So we are doing progressions telescoping series today. So I'll tell you what is telescoping series. So if in a series you can express rth term, telescoping series. So if you have rth term, so your series, let me write the series first. So if you have a series like f of 1 plus f of 2, I'm writing as a function of f of 3, this is the third term, and so on. This is the, okay, wait a minute, sorry. Let me again write it clearly. So if you have a series which you need to find the sum of the series, its first term is t1, second term is t2, third term is t3, and so on. Rth term is tr. All right, and you need to do it up to say n term, to n terms, infinite terms. Okay, so n can be anything. So what you need to do in this telescoping series, you need to express this. The method we use to solve this series is called difference method. Okay, so what is this difference method? We express this rth term as a function of r minus function of r plus 1. All right, or you can write function of r plus 1 minus function of r. Okay, this way also. So you express your rth term in this way: function of r minus function of r plus 1, or function of r plus 1 minus function of r. It might be function of r and function of r plus 2 also, but in that case then remaining terms will be 4. In this, if you solve it, okay, so first let's solve it, then I'll explain. If you have what function of r and function of r plus 2 or function of r plus 3, then what will happen. So see, if I write t1, then t1 is going to be f of 1 minus f of 2. Then t2 you can write, t2 is going to be f of 2 minus f of 3, all right, and T3 is going to be f of 3 minus f of 4, and so on. Then you can write up your last term Tn. Tn is going to be f of n minus f of n plus 1. So if you add them, if you add all the terms to left hand side, you'll get the sum. So that is Sn, sum of n terms. You can see if you add this series, then these terms will get cancelled, right? Okay, these terms will get cancelled. You get only first term f1 and the last term f of n plus 1. So that is f of 1 minus f of n plus 1. So directly you can remember like this. If we have function of r minus function of r plus 1, then put r is equal to 1 in this, and last value of r, which is n in this case, in this, all right, and write the answer f of 1 minus f of n plus 1. If I write the answer here, then in this case terms will get cancelled like this, all right, if you write t1 t2. So what will be the answer? Last term remaining for r is equal to n, this term will be remaining, and for r is equal to 1, this term will be remaining, all right. So after cancelling everything, here sum is going to be Sn is equal to f of n plus 1 minus f of 1. Okay, so I hope you're getting it. I mean, your first term is function of r or the second term is function of r, you need to put r is equal to 1 in that, and in function of r plus 1 you need to put r is equal to n, okay, last value of r, and you'll get the answer in this only, all right, in this. For example, let me give you one example. Suppose your series is 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4, and so on. Okay, 1 upon n into n plus 1. You need to find the sum of this. So if you write the rth term of this series tr, so that is going to be 1 upon r into r plus 1, all right. 1, 2, 3, you can see it's a simple natural number 1, 2, 3. So rth term will be r, and the next term is 1 greater than this, so r plus 1. If this is your rth term, then how do we split this? See, terms are in AP basically, these two terms, okay, so same AP, same is 1, 2, 3, this is first AP, 2, 3, 4, it's the same, it's the same AP with common difference 1, all right, but it's starting from 2. So in such cases, when you have two series, two HPs, you can say this is a product of two HPs, right? Or you can say APs are in denominator, right? Product of two APs in denominator. So if two HPs are in product whose corresponding APs have same common difference, then you can split this easily, all right? See, the difference of these two is 1. So write the numerator as the difference of these two, which is r plus 1 minus r. This is called partial fractions also, and using that you can split this term easily. So now divide, you'll get r 1 upon r minus 1 upon r plus 1. You can see this is function of r and this is function of r plus 1. So if you want to write the answer directly, you can write Sn is going to be, put 1 in this and n in this, all right, because this is function of r plus 1. So this, in this way it will get cancelled. So it is 1 minus 1 upon n plus 1. This is your answer. But if you write it completely, then you can write it, no problem. You write T1. Let me explain. So T1 is going to be, wait a minute, let me check my voice once again. All right. So T1 is going to be 1 minus 1 by 2. T2 is going to be 1 by 2 minus 1 by 3. T3 is going to be 1 by 3 minus 1 by 4, and so on, right? You can write Tn also. So Tn is going to be 1 upon n minus 1 upon n plus 1, and add these terms. So now you can see in this way all the terms will get cancelled, and sum is going to be 1, this term, and minus this term, minus 1 upon n plus 1. All right, so this is going to be your answer. I hope it is clear. Now let me give you another example. So if you have a series 1 into 3 into 5 plus 1 upon 3 into 5 into 7 plus 1 upon 5 into 7 into 9 and so on, okay, to n terms. This is a series. Now you can see now 3 HPs are there's a product of 3 HPs, okay, or in denominator you can see it's a product of 3 APs which have same common difference. If you see this AP 1, 3, 5, its common difference is 2, 3, 5, second term, 7, this is again AP with same common difference 2, and 5, 7, 9, this is third AP with same common difference 2, alright. So if you write the rth term, wait a minute, let me plug in my computer laptop. Alright. Okay. Good to go. Alright, so let's write the rth term. So 1, 3, 5 and so on. So rth term of this series is going to be 2r minus 1. It's a series of odd numbers starting from 1, so rth term will be 2r minus 1. 3, 5, 7, this is again a series of odd numbers, but it's starting from 3, so it will be the rth term of the previous series will increase by 2, so it is going to be 2r plus 1. And then last 5, 7, 9, rth term of this is going to be 2r plus 3, again increase it by 2. So rth term of this our required series is 1 upon 2r minus 1, 2r plus 1 and 2r plus 3. Now see, when you have more than 2 series is in product, more than say 2 HPs, or denominator mean you can say 2 APs are in, more than 2 APs are in product, then write in sequence, like 1 is the first AP, second AP, you can see first term of AP is increasing, right, in all the APs. So you have 3 APs in product, then whose difference of any two will be constant. Difference of first and 2 is second is constant, difference of first and third is constant, difference of second and third is constant, but with difference we need to write in the numerator. So we need to write the difference of first and last. So you can see in this case difference of first and last is going to be 4. So we need to multiply and divide by 4, okay, first of all. So we are creating this 4. So as long as this difference is constant, there's no worry. You can create this. You can multiply and divide by constant. Alright. So I have multiplied and divided by this constant 4. Now this 4 in numerator can be written as 2r plus 3 minus 2r minus 1. Alright. Divided by this whole thing, which is 2r minus 1, 2r plus 1 and 2r plus 3. Now you can divide. So if you divide by this, it is going to be 1 by 4. Okay. So first term is going to be 2r plus 3 will get cancelled and you'll get this, okay. So which is 1 upon 2r minus 1 into 2r plus 1. Alright. Minus 1 upon, if you divide the second term by this denominator, you'll get 2r plus 1. This will get cancelled. The first will get cancelled. And the remaining will be product of last two, that is 2r plus 1 into 2r plus 3. So you can see this pattern will maintain if you cancel first or last, but if you cancel the middle term, then first and last will not form the same sequence, because difference is going to be 4 now. So we are not cancelling the middle term even if you have more than 3 terms. All right, always cancel the first and last. All right, so if you cancel the first term and last term, the remaining terms will form a function of r and function of r plus 1 always. Like in this case, this is function of r, this is function of r, and if you put r is equal to r plus 1, this is going to be function of r plus 1. So if you want to write the answer, you can write it directly as in 1 by 4 will be there. Okay, you need to put 1 in this, r is equal to 1 in this, and r is equal to n in this. All right, in this way all the terms will get cancelled. Terms will get cancelled like this if you write all the terms. All right. So put 1 in the first term. So if you put 1, it is going to be 1 into 3 minus, if you put n in this, it is going to be 2n plus 1 into 3 2n plus 3. So that is going to be your answer, all right? So I hope it is clear. Now let's move to another problem. So one more example and then we will begin our session. Let's start practicing questions. So example 3. Suppose you have 1 upon 1 into 2 into 3 into 4 into 5 plus 1 upon 2 into 3 into 4 into 5 into 6 plus 1 upon 3 into 4 into 5 into 6 into 7 and so on up to n terms. Now how to do it? Perhaps you have got it right. Now this is a product of 5 HPs, okay, or in denominator you can say it's a product of 5 consecutive APs. All APs have common difference 1. Okay, so if you write the journal term TR, it's going to be Rth term of this 1 2 3 4, so it is R only. Then Rth term of this 2 3 4 5, so that is R plus 1. Then 3 4 5 7, so R plus 2. Now keep increasing it, keep adding 1, all right? So next Rth term of the next is R plus 3, and the next term of Rth term of the next is R plus 4. That's it. So you have 5 terms in product, so this is the 5 terms. Now what to do? As I told you, you need to write numerator. You need to express numerator as a difference of these two. All right. Difference of any two is constant, but you don't need to take any two. You need to take only first and last. Difference of first and last. So difference of first and last is 4. So again multiply and divide by 4, and write this 4 in the numerator as r plus 4 minus r. All right. And divide by this r plus 1, r plus 2, r plus 3, r plus 4. Okay, so after dividing you will get 1 tr is equal to 1 upon 4, and after dividing you'll get 1 upon r into r plus 1 into r plus 2 into r plus 3, all right, minus this is going to be, it will start from r plus 1, r will get cancelled, r plus 2, r plus 3 and r plus 4. So now you can see which one is function of r. This is function of r and this is function of r plus 1, right? So in this way again terms will get cancelled, and you need to put r is equal to 1 in this and r is equal to n in this, all right? So your sum Sn is going to be 1 by 2 of, put 1 in this 1. So there's 1 upon 1 into 2 into 3 into 4, which is 24, minus 1 upon, put n in this, so it is going to be n plus 1 into n plus 2 into n plus 3 into n plus 4. So you can also be asked to find the sum of infinite terms in such sequences, all right? That is basically telescoping, all right? That is telescoping. When it converges to, terms are decreasing, all right? And they can be expressed as a difference of function of r and function of r plus 1, all right? So in that case you can find the sum of infinite terms also. So if I apply this limit as n is approaching to infinity, this n infinity is going to be 1 by 4. This is 1 by 4 over this, minus, if you apply approaching to infinity in this, it is 1 upon infinity, and 1 upon infinity is going to be 0, close to 0, right? Approximately. So 1 upon 4 into 24. This is your final answer. 1 upon 96. The sum of infinite terms is very useful in such series. So always express as function of r minus function of r plus 1. So find the sum up to n terms and then apply the limit. And after applying the limit, you will most of the series is second. You need to find the sum limit of this term only, right? Because this contains n. So in most of the cases it becomes 0, but it's not mandatory, okay? It might be some other non-zero constant also. But asking the sum of infinite terms uh, in JEE exam, alright? So now let's begin the session. This is your first sum to do. So as I told you, we have already done it. You just find the sum of two infinite terms now. We did it to n terms. Now you need to find the sum of two infinite terms. So you try it, and then I'll discuss with you. So try it for a minute. Okay, so this sound is not proper. I need to figure it out. Hello? 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 Yeah, it's fine now. Alright, so continue this. Alright, so let's discuss it. As I have written the sum of first R term, you can write generally 1 upon R is equal to TR. First write the R term of this series, okay? Just leave this 12 R term of this series. We'll multiply 12 later, alright? We are finding sum of this series which is written inside the brackets, We'll multiply 12 later. So TR is going to be 1 upon 2R minus 1, 2R plus 1 into 2R plus 3. That's it. Then we wrote the difference of first and last, so that was 4, so we multiplied and divided by 4. I'm writing that directly because we have already done it. Then 2R minus 1 into 2R plus 1, and we were getting 1 upon 2R plus 1 into 2R plus 3. Then we can put R is equal to 1 in this, n in this, alright. So sum of n terms is going to be 1 by 4 into 1 upon 1 into 3 minus 1 upon 2n plus 1 into 2n plus 3. One three five 357 so 579 to infinity 2r minus 1 2r plus 1 2r plus 3 difference is 4 multiply and divide by 4 and 2r plus 3 minus 2r minus 1 into 2r plus 1. So that is the sum actually. If you apply it to infinite terms, n is approaching to infinity, it is going to be 1 by 12 only. So these options are, I think, wrong. Yeah, options are wrong. So correct answer is actually 1. So if you need 12 times of s of n, that is going to be 1 only, okay? N approaching to infinity. So this answer, let me make this 1, any of one of the options. Let's make it 1, okay? So one of the options should be 1. So 1 is the correct answer. All right. Now let's do the next problem. Okay, let's do this. This r plus 1 factorial is basically 1 into 2 into 3 into 4 into up to r plus 1 factorial, up to r plus 1. These numbers are also in AP. Alright, so let me explain this. See how to do it. So if you write the Rth term, which is Tr is equal to r upon r plus 1 factorial, then how to split it? See, if you add and subtract plus 1 in the numerator, r plus 1 minus 1, then after dividing, r plus 1 will get cancelled in one of the term, right? And if r plus 1 will get cancelled, then what will be remaining in the numerator and denominator, sorry? See, r plus 1 factorial can be written as r plus 1 into r factorial, right? So r plus 1 will get cancelled and 1 upon r plus 1 factorial will be there. So it is 1 upon r factorial now minus 1 upon r plus 1 factorial, right? And you can see that this function of r and this function of r plus 1. So if you write tr again, 1 upon r factorial minus 1 upon r plus 1 factorial, then this is function of r and this is function of r plus 1. So in this way terms will get cancelled, right? You can put 1 2 3 or directly put r is equal to 1 in this and r is equal to n in this, okay? Because you need to find the sum up to n terms. So sum of n terms is going to be 1 upon 1 factorial is 1 minus 1 upon n plus 1 factorial, right? So n plus 1 factorial, that is your answer. I hope it is clear. Let me give you another example if it is clear to you based on factorial only. Suppose your question would have been this, sigma of r into r factorial, alright? Now try this one also, r from 1 to n. Then how would you split it? It's a similar question, that's why I'm adding this question here. So as you have done one question on factorial, this is another question factorial. So try this one also. It also includes the similar concept, the similar manner you can do it. All right, so let's discuss this. I hope you have done it. So TR, we'll write TR is equal to R into R factorial. Like in the previous question, we'll add plus 1 to this and minus 1 to R, okay, which is written outside this R factorial. Now you can club R plus 1 into R factorial. So that is going to be R plus 1 into R factorial. I'm writing this now. In next step, I'll write it R plus 1 factorial minus R factorial. So now you can write TR is equal to R plus 1 factorial minus R factorial. I hope it is clear. And then you can this is a function of R plus 1 and this is a function of R. So in this way, like this, terms will get cancelled. So you need to put R is equal to 1 in this and R is equal to n in this. Alright, so sum Sn is going to be n plus 1 factorial minus 1 factorial, which is 1. Okay, so answer is n plus 1 factorial minus 1. This is your answer. So I hope you have got this factorial type of questions. Again, we have a good question based on factorial only. All right. So find the sum of the series. Again, try to split. This is a very, very good question. So try to split the rth term. See what to do. Try this one. This is a very, very good question. All right, so let's continue. Let's discuss this. If I write the rth term, it is going to be tr is equal to yeah, so r square plus 1 into r factorial. I hope you have written this rth term, all right? Because 1 square plus 1, 2 square plus 1, 3 square plus 1. So rth term will be obviously r square plus 1. And these terms are multiplied with 1 factorial, then 2 factorial, then 3 factorial, right? So rth term will be multiplied to r factorial. Simple. So you can see the pattern and you can write the rth term. After writing the rth term, you can see, you can split it easily. R square plus. So you can add plus r and subtract plus r, minus r, plus 1. Why am I adding this? I'll tell you. So I've already done, because you'll have to do some hit and trial, you'll have to add plus to r, you might make it perfect square. So after doing all that, you'll come to this, adding plus r and minus r will make it r into r plus 1, one pattern. Minus, if you take minus in common, because you need minus also, in between r minus 1, right, like this, into r factorial. If I multiply this r factorial inside, then this r minus will not be clubbed with r factorial. I mean, it won't make r plus 1 factorial take. Like if you multiply r factorial with r plus 1, it becomes a new factorial, a factorial of r plus 1, right? But in this case, r minus 1 can't be taken inside the factorial. You'll have to write r minus 1 factorial outside only. So it is going to be r minus 1 into r factorial. All right. So this term will remain like this only. Okay. Now, but if you multiply this to r factorial, then r plus 1 into r factorial will become r plus 1 factorial, right? And you can see this r will still be there outside. So r is there. And now you can see this pattern is same as the pattern you can see in the second term, right? In fact, this is if this is function of r, then this is function of r plus 1. If you replace r by r plus 1 in the second term, it will become the first term. All right. So now you can see this was the way to split it. Now you can cancel the terms. Terms will cancel like this. So one term will be remaining here and one here. So r is equal to 1, you need to put in this, and r is equal to n, you need to put in this to write the answer. So Sn is going to be n into n plus 1 factorial minus, if you put r is equal to 1 in this, this is going to be 0, right? So your answer is n into n plus 1 factorial. So what is the answer? You can see B option is the correct answer. Option B. So I hope you have got it. Now let's do this new problem. Try this one. Okay, so let's do it. If I write the rth term of this series, TR, and that is going to be, by looking at this pattern, you can see The other term is going to be 1 plus 2 plus 3 plus 4 and up to r. All right. This will be the other term, right? So you can add this series. It is very simple to add. You know that 2 upon it is r into r plus 1. And I can see you have raised to our first problem which we have discussed. So this was just another way of writing this problem. The problem was very simple. Actually, this was the first problem we started with today. So now you can write this as numerator can be written as difference of these two, r plus 1 minus r. Make this 2, take this 2 outside because difference of r plus 1 in r is 1. So you just need 1 inside, okay, in the numerator. So r into r plus 1 and then divide. So after dividing you will get 1 upon r minus 1 upon r plus 1. All right. Now put 1, 2, 3. So let me write the answer directly. So it is, okay, you can write like this. It is 2 upon r minus 2 upon r plus 1. Okay. So this is your function of r and this is your function of r plus 1. So in this way terms will get cancelled. All right. So there's going to be t sn, sum of n terms is going to be put 1 in this, r is equal to 1 in this and r is equal to n in this. So it is 2 upon 1 minus 2 upon n plus 1. Okay, so this is going to be your answer. Now this is our next problem. Try this one. This is again a very good question. We'll discuss this next. All right. So keep trying this method. We have a lot of questions to discuss in this method. Hello. I think up now I will be audible. Let's see. Yes, yes, this is live. Yeah. This problem just started because I just checked the sound few minutes back. Alright, so we were doing this problem, alright? Okay, so I'll write it again because by mistake I have erased everything. So that TR was this 1 upon under root of, yeah, thank you. So this is A plus RX plus under root of this A plus R minus 1 into X. So if you rationalize, it is going to be under root of A plus Rx minus under root of A plus R minus 1 into X, alright? So divide, this will be A plus Rx and minus A plus R minus 1 into X. So we did this, okay? So we were doing rationalization of the denominator so that we can express this Rx term as a difference of two functions, function of R and function of R plus 1. So now you can see denominator is nothing but a and a will get cancelled, and this rx minus r minus 1x is x. So you can write like this: a plus rx divided by x minus under root of a plus r minus 1 into x divided by x. All right. So this is your rx term. Now you can see this is your function of r, and this is your function of r plus 1. So the terms will get cancelled like this, okay? So you need to put r is equal to 1 in this and r is equal to n in this to find the sum up to n terms. So this sum up to n terms is under root of 1 plus, sorry, not 1, a plus. This is a plus nx divided by x. Because x you can take common, and minus, if you put 1 in this, it is going to be under root of a only. So you can see, yes, which option is correct. So B clearly you can see, and also you can rationalize it and you might get A option also, okay? So let's rationalize it and check. So B option is already correct. B option is correct. We can see that. And after rationalizing, we can express the answer in other form also. So if you rationalize it, it is going to be nx in numerator divided by x into under root of a plus nx plus under root of a. I'm writing it directly. So x and x will be cancelled, and yes, you can see a is also the correct option. So two options are correct, A and B. So this was the beginning of telescoping series. We'll continue this telescoping series tomorrow, uh, and we'll do a lot of good questions of telescoping series tomorrow. All right? Yes. Thank you, buddy. Thank you for, and your options are correct, A and B. Okay, so I'll continue this telescoping series tomorrow. So if you're interested, you can join tomorrow also. All right. So, take care.